Okay, here we're going to talk about doing Fourier Series with Simulink. I've got MATLAB open. I click on Simulink Library, and I get my usual Simulink browser. Let's kind of stop this down a little bit. File, New, Model. Let's create a model here. We'll put that down in the lower right. Now, what we're going to do is we're going to add up a bunch of sine waves and see if a Fourier series actually does work. So I'm going to go to Sources, and I'm going to take a sine wave over here. Then I'm going to go to Sinks, and I will take a scope over here. And then I want to go to some math operations, and I am going to get an adder. And what we can do right now is just put one sine wave in there. Okay, so now I've got a sine wave to an adder to a scope. And if I run that guy, double click on my scope, there you go, I've got a sine wave. Alright, well that's good, we'd expect that. But now let's come along here. Well, actually, let's double click the parameters on the sine wave and see what we've got. Now you got to be careful here. You could really make a mistake. Make sure this is on time base, not sample base, because the parameters change. Make sure this is on simulation time, not external time. Otherwise, you're going to have a problem. Time base, use simulation time. Right now, that's at omega equal to 1 radian per second. All right? So that's good. So let's copy this and let's just paste. And I'm going to hit Control V and paste a few more times. Yeah, we'll put a bunch of them in there. There's sine wave 2. Oh, actually, let's do sine wave 1, sine wave 2. We'll run this guy up here. Let's see, where's my 3? Sine wave 3, sine wave 4, sine wave 5, sine wave 6, and sine wave 7. Okay, let's open this guy up, make it a really big adder. Okay. And let's see, how many am I going to add up? 1, 2, 3, 4, 5, 6, 7, 8. So let's double click the adder and we'll put 8 plus signs. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. All right. Apply. Then what I'm going to do is change the frequency of these guys. I'm going to change this one. Now be careful, don't change the sine type and the time, otherwise you're going to mess up. So let's make that guy 2. Okay. Let's make this one here have a frequency of 3. Okay. Let's make this one have a frequency of 4. Okay. And let's make this one have a frequency of 5. Okay. And let's see, let's make this one have a frequency of 6. Okay, and then let's have this one be a frequency of 7. Okay, and then we'll have this guy be a frequency of 8. Okay. Now let me show you something. Notice all those sine waves they're just a sine wave glyph. Let's go down to sine wave 7. And let's say you double click that guy, but then inadvertently, you were scrolling this, but maybe you changed from simulation time to external time. Well, you're still going to have your frequency of 8, and then you're going to think, oh, okay, I got it. But then you see that little T right there? Well, notice all the other ones don't have a little T there. Well, that's a problem because that's not going to generate. It's going to look for an external signal. You want to use the signal that's associated with the simulation. So make sure that's use simulation time, and notice that little T went away. All right, so we've got 8 sine waves, all at a different frequency. Let's all run them into my summer here. That was 2 omega, this was 3 omega, that'd be 4 omega, this would be 5 omega, this would be 6 omega, 7 omega, and oops, I need an 8. Looks like I got to add one. Oh no, wait a minute, what did I do here? I missed one. Yep. Okay. So we kind of missed one here. Let's see, so I want 4 to go up to here, 5 to go to there, and 6 to go to there, and 7 to come down to, let's see what's going on here. Oh, I see I've already got a connection there. I didn't delete it. And now we've got all those guys going into my summer. All right. Well, let's add them all up and see what happens. Do we get anything interesting? Yeah, we get something that's periodic, but not exactly what we want. Well, the issue there is all these sine waves have the same amplitude, and they're all being added together. Well, let's see if we can kind of change that in the adder. Let's go to the adder, and instead of having 8 pluses, let's do plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. So now I've got 8 entries, and then I'm alternating between plus and minus. Okay, let's run it again. Okay, well, you know, we still got something screwy. But the issue here is we need to modify the amplitudes of those sine waves also to make them correspond to a Fourier series. We'll keep the first one at 1 radian with an amplitude of 1. Now the second one I'm going to make it 1/2. All right, so I'm going to change this guy to 1/2. This one's going to be 1/3. Okay. And let's see, this one will be 1/4. Okay. And this one will be 1/5. Okay. And let's see, this one will be 1/6. And this one should be 1/7. So we're basically just using the equation of a Fourier series here. And this last one should be 1/8. Now, a Fourier series will really go out to infinity, won't it? Which one is this? This is like 1/8, yeah. Yeah, so this has amplitude 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, and 1/8. And then notice I'm alternating the signs. Well, if you go look at the Fourier series, for a triangular wave, I think it is, you'll see that we've implemented that equation. So now keep an eye on the plot down here, and let's run it. Wow, look at that. We're starting to get like a nice little triangular wave. Actually, more like a ramp. Yeah, more like it kind of ramps up, drops off, ramps up, drops off. And we've only implemented the first 1, 2, 3, 4, 5, 6, 7, 8 terms. So we have the fundamental and then 7 higher harmonics. Well, of course, the series goes to infinity, and when you do that, you're going to get straight lines and really nice sharp edges. The nice sharp edges come from high frequency terms. Now, what if you're not getting this result? Can you debug this? Well, what I would do, I would come along here and throw another scope in here. And this would kind of maybe be my debug scope. Okay? And then, let's see, what I would do is I would just check each signal. Okay? And then I'd put these 2 plots on top of each other. And there you go. Okay, so great. That first one's generating a sine. Then I'd go over here, delete that, and then let's check out my second signal. Run it again. Yep, there's a sine wave, you know, twice much frequency. That one's good. Because it may be such that you inadvertently changed some parameters and didn't realize it. But, you know, you come down here, you could check this term right here. And then run it, yep, and there's a higher frequency. Notice the amplitude shrinking down, so you can test it out. But the fact that you got a nice little, you know, ramp function down here that's getting more and more linear as you add more harmonics suggests that you did it right. So there you go. There is using an example of using Simulink to kind of do a limited Fourier series. All right, thanks for watching.